using one in class, been talked about, graphing?
Yeah.
Okay. All right, so here's the scenario. A diver is 48 feet above the water and is leaping off a diving board with and this is actually an initial velocity, which is important, of 8 feet per second. How long will it take the diver to reach the water? So scenario here is, you ever been on a diving board?
Yeah.
So they jump, and I guess we don't know whether they jump up or down, but they hit the water below and they dive in. All right. The nice thing here is they give you an equation. You probably saw that at the top there. Have you taken, well, you're still first year. I was gonna ask if you have taken physics. Physics usually comes a little bit later after chemistry for most students. You'll do this all the time in physics, this equation down here. Okay, and see how it starts out minus gt squared. That's a squared. G is gravity, plus vt, which is the initial velocity. That's why I changed it to initial up here, initial velocity, and h is the height. Okay, so it's how high up you start. Any questions on that before we start plugging in numbers?
No.
Okay, so G is 16. G is 16. So this is minus 16. Now they're using X instead of T. So we're going to follow that, X squared. That's right there. V is 8. So plus 8 T. All right. And then how high up is she starting? How high is the diver starting up?
45 feet.
48 there.
Oh wait, it's hard to see.
Yeah. So the responsibility is that for you as the student here is like, can you figure out what numbers go where? And I'm sorry, this is an X, not a T. Any questions on that?
No.
Okay. So here's what I'm doing on the other screen here, and I'm going to snip it in real quick. Is I'm going to show you the picture of what's happening here, so you can see what's going on. You snip this in. I think the graph's important. So here is the diver at the top, and here's the water down here. So they actually slightly go up, and then they come down. All right, is that okay?
Yeah.
So I'm just graphing this equation. What are you trying to find? So it says, how long will it take the diver to reach the water? What are our options in this drop down here?
Maximum, minimum, and y-intercepts. X and y-intercepts.
Okay, so we are looking for the x-intercepts.
Okay.
Does that sync up with you? Because this is when y equals 0 or f of x equals 0.
Yeah, that checks out.
Okay. Now this next part says what values make that true. That's where we actually have to do some work here, and what we are doing is setting that equation equal to 0. And like for the last month, that's what you've been doing. You've been solving quadratic equations. All right, so you're supposed to look at this and be like, oh, I know how to do this. Maybe, right? Like that like maybe you do, maybe you don't, but like you should say, okay, it's a quadratic. I think I can try to solve this.
Yeah.
Some are easier than others. I'll help out here. Let's factor out a -8 as a GCF. Okay. The reason -8 goes into all three of them. Negative because the leading one is negative. So that's 2x squared minus x minus 6 equals 0.
Okay.
All right. Now, what type of factoring is inside here? Or if you don't know the name, that's fine. What do you do? You know, what's the
Gotta find I'm looking at it and like trying to make it click in my head because I know how to do this. I just
yes. We've done a lot of these, but it's okay. It's not. I'm just asking because it's good if you try to take an attempt to say, okay, I think it's this or that.
know my dog. Um,
So it has to do with this first number and this last number.
oh, you gotta put them. Is it the multiply them together thing?
Yes,
And
yes.
figure out. Okay.
So I'm gonna write. I'm just give a little more room here. 2 times minus 6 is minus 12. You're looking for two numbers that multiply to minus 12, but add to -1.
Um, -3 and 6. I mean -3 and 2.
They got to multiply to -12. So those multiply to -6. You're close.
Wait.
It's a 4 and a 3. Which one's positive? Which one's negative?
-4 and 3.
Yes. So then it's a grouping thing. So you're gonna probably group the -4x with the 2x squared. Do you remember what to do from here?
Put them down the middle and do the find the greatest common factor of the first two.
Okay, with the first two. Yep. What would that be? What's the
2x.
okay?
Uh,
So it becomes x minus 2 and x minus 2. What goes in between them?
3 plus 3.
Plus 3.
Yeah.
So then you factor out the x minus 2, and you have 2x plus 3 equals 0. Still a little bit more to do here. How do you finish this off?
Find the put the 0 into each equation.
Yeah, you
and
set them equal to 0. Each of the idea here, Maris, is that it's like if this first one is 0, 0 times anything is 0, or if the second one is 0, 0 times the first one is 0. So that's why you set each of them equal to 0, because only one or the other has to be 0 for the whole thing to be 0.
So it's x equals 2 and x equals -3/2.
Yes. All right. Now we see from the graph that it's 2, but I don't have -3/2. What does so this is in time, so it's saying like 2 seconds it hits the water. What do you think about this negative answer here, or did you see that in class at all?
Um, I don't remember exactly.
Okay, so the idea here is that the quadratic has two solutions, but the physical problem only has one. You only hit the water one time, right? Hit the water, you're done. There's no like, it's not like you jump backwards and hit the water.
Yeah.
So in these problems, you have to be careful to recognize that, okay, there's actually only one solution. If you look at the way it's written, it says what values make that true. There's two values, the 2 and the 3/2, sorry, -3/2, but only one works in the real scenario. So in this case, you would say 2 seconds later, or 2 seconds after jumping off.
Yeah.
Okay, now I noticed this as I was scrolling through the question here, and I'm going to just snip it in here. So there's like a lot of analogies we could draw, but let's just take a look at this here. It says write the formula and solve. Don't forget, quadratic formula always works. What do you think that means here?
The quadratic formula can be used.
Yes. So if you got to this point here and you're like, I don't know, I'm not sure. You know, I make the analogy, people that work with tools all the time, the hammer is like the quadratic formula. Like a hammer will work in like every scenario, but you know, you wouldn't use a hammer to take a screw out, but you could. Like it just, it would work. But it's just, so be careful. Like you can always use the quadratic formula, but is it the right tool for the job? You know, that's for you to think about and decide.
Okay.
All right, number 2. Well, you said you're using animation software a while back, and
Yeah.
I guess I want to like that's kind of like you know, when you're using software, sometimes you're like, oh well, I always do this because it always works, right? Like you always go to something because you say, oh, that'll do what I needed to do. Can you think? I mean, is there any parallel to that world where there's something that always works when you're doing animation stuff?
Um. Yeah.
Okay. Always good to see if you can draw some parallels to your real life, you know. Because like, you know, a dolphin leaping out of the water. Yeah, I mean, we live in Arizona. There ain't a lot of dolphins leaping out of the water here. You know? So anything you can do to kind of attach it to realistic scenario is always good. All right. So it says a dolphin leaps out of the water at a velocity of 20 feet per second. So it's assumed now that we're still using the same equation as the first problem that we did. Okay, this S of t, and again, I don't know why your teacher chose f of x because it is S of t here, minus gt squared plus vt plus h, and they're telling you that g is 16. Okay. What does the 20 represent in this equation down here?
Uh. The VT.
Yes, it's just the v, so it's plus 20t minus 16t squared. Now, because it leaps out of the water, like it's imagine here's the water, it leaps out, comes back down. What does h equal at the water level?
Um. 20.
0.
Oh, 0.
0. So if you're ever starting from the ground or the water level or where it hits the ground, your height is 0.
Okay.
All right, so that's your formula. They want it in terms of X. There you go. There's the why is there like a duplication of these three questions? Oh, I'm sorry. There's two questions here. That's why. All right, so we'll look at the first one. How long will the dolphin be out of the water? So that's these three questions on the left here. Is that okay?
Yeah.
So in terms of the quadratic, what we're looking for is this point. I'll call it point 1 here on the right. We're looking for where it hits the x-axis. Comes up, hits the x-axis, and it starts out at the origin, but we know that it comes up and hits the x-axis.
Yeah.
So is that one of the drop downs?
Yes.
Okay. So that's the first box there. What values make that true? What did we do in the last problem? We were trying to find the x-intercept.
Did the solving the thing.
Okay, be a little bit. Let's go back and look here. Let's be a little more. What is this on the right here?
Equal to 0. So
Yes. So you set this equation equal to 0. Plus 20x, set this equal to 0. Okay. You can use the quadratic formula. I would not recommend that in this problem, but you could. Yeah, what other thing might work here?
doing the greatest common factor thing.
Yes. Yes, very good. What is the greatest common factor as a number and then with the variable?
Oh no, my dog. I got it. Sorry.
Yeah, take your time. Get the dog situated.
Oh, my dog. Okay, sorry about that. I'm back.
Okay. Yeah, if you ever need to step away, that's fine. What is the GCF here between the two numbers, 16 and 20, and then between x squared and x?
Negative 4t.
Yeah. Now, yeah, I'm doing x because the way the problem is written, it seems like it's once in terms of x, but yes, 4t is correct. Sorry if that's confusing. So that becomes 4x minus 5 in here.
Yeah.
And just like the last problem, you have to set both of those equal to 0, minus 4x equal to 0 and 4x minus 5 equal to 0. Can you solve those for us, please?
Sure. I got 4/5 and 0.
Okay. It should be 5/4, right? You're going to add 5 first. 4x
Oh, yeah.
equals 5. Divide by 4.
5/4.
And then x equals 0, also good. All right, which one do we want? Which one is at 1? Is it the 5/4 or is it the 0?
5/4.
5/4, good. So that is your answer to this. Now, again, it's kind of written weird. So it says what values make it true? It's both of them, but it's the 5/4. It's the It's the 1.25 seconds later. And there's some reasonableness to that. You know, dolphin, I mean, I don't think a dolphin's spending a ton of time out of the water.
Yeah.
All right, ready to go on to the maximum height of the dolphin?
Oh, sure.
Right. So that's these over here. So in terms of the quadratic picture, I guess I'll switch to a different color, blue. That's this point at the top here. But the point at the top there has two values. It's got an X and a Y there. Are we interested in the X or the Y value at 2?
The Y.
The Y value, yeah. So I don't know how it's the Y value of the vertex. All right, so we have to calculate the vertex of this equation. Do you remember how to do that when it's in this form? The X coordinate is minus B over 2A.
Okay.
What would that be here?
20 over 36, 32.
So B is 20, so it's negative 20 up top, and then 2 times negative 16 on the bottom.
Oh yeah, it'd be negative 32.
Yeah, so whatever this becomes, you can go to a calculator if you need to. But we have to use the X value back in the original equation. So you have to take this number here, which is 5/8, and put it back in for X. Okay, so using a TI 83, 84?
I got Desmos.
Yeah, Desmos, even better. Minus 16, you can put 5 over 8 in parentheses and square it, plus 20 times 5 over 8. If you enter it exactly the way it's written, the Desmos knows how to calculate it for you. It's very intuitive to use.
Got 6.5 or 6.25.
Yes, and that's the Y value of the vertex. Now there's only one Y value here. There's no, like when we go back to, keep saying values. I don't know if that was a typo by the instructor, but in this case, there's just that value, and it is the max height of the dolphin.
All right.
All right, so let's move on to the next question here. Number 3. All right, have you ever been to New York City before?
Yeah.
Did you go on top of the Empire State Building?
Yeah. It was awesome.
You were not allowed to throw objects off the Empire State Building because they hit
Yeah.
the ground and they caused a lot of damage. Okay, just like the last problem here, it's minus gt squared plus vt plus h. Could you use these values? And g is 16. Could you write this equation for me? Let me know what you come up with.
Sure. I got minus 16 x squared plus 38 x plus 1250.
Yes. Yes. Now we've not seen this yet, but in all these scenarios, you're always throwing the object up, which is fine. You could throw the object down, but in this case, you're throwing it up, and it hits the ground in this scenario. Okay. Typically in these problems, they're either asking you for information at 1 or 2. Okay, so let's read what it says here. How long will it take the object to hit the ground? Are they asking about 1 or 2 in this problem here?
How long? That'd be 1.
Yes. So they're looking for the x-intercept.
Yeah.
Okay. How do we find the x-intercept when it's in this form?
Gotta set it to 0.
Set it equal to 0, yes. Now this factor, I can tell you. I'm tempted to say that it doesn't. You have to decide here if it's worth spending time to factor something that you don't have any guarantee that, like your instructor says, go right to the quadratic formula. What do you
Like
think
maybe
about that?
I kind of want to try it with the quadratic formula just because that's a possibility.
Yeah, it will always work. And graph, we want to use the quadratic for this. It is not a nice number. What's the value of A, B, and C for the quadratic formula here from the equation?
A is negative 16, B is 38, and C is 1250.
Yes. All right, so minus B plus or minus squared minus 4AC over 2A. Now, are you allowed to use Desmos in class? Probably asked you many times, but sorry, because I got an idea here for you that might help.
Probably.
You might be able to use this in class.
Yeah.
Desmos. Okay, so here's what you can do, and I think you'll like this. You can actually just type A equals minus 16 and hit enter. B equals 38 and hit enter. C equals 1250, hit enter, and then X equals and write this formula, and it will substitute all the numbers for you. And if you're not sure what I mean by that, I can type it out here or switch my screen and show that. So let me snip this in because there's a different way to do stuff depending on what tool you're allowed to use in this case. So that's what I meant by this, like A equals -16, enter, B equals 38, enter, C equals 1250, enter. And then you type in the formula down here. You don't have to put any of the numbers in.
Huh. That's cool.
Yeah, I agree. It's fast. You know, you don't have to fumble around with, putting the numbers in and squaring and did I take the square root? But this is not the answer. This is one of the answers. To get the other one, you have to change this plus to a minus. So that you could, for example, copy and paste this into the next line and change it to a minus, or just change this to a minus. Lots of options. So let me know what you come up with for that one.
I'm having a little trouble with the calculator. I can't get the square root divided by 2a to go under the whole square root.
Yes, yeah. So you kind of have to look ahead, and one of the things you can do is highlight everything and then do a slash, or do the slash from the beginning, and then it will give you the fraction bar.
Okay, I figured it out. I did the thing.
Oh, good, nice. So obviously this one's no good because it's negative. Do you have the positive one for me?
Yeah, sure.
Or I guess switching the sign here so that this becomes positive.
Negative 29.081.
So the only thing you're changing is the plus to a minus here. So do you have the same numbers, -16, 38, 1250?
Yeah.
Is this one the same? The -7.73?
Oh wait, I know what I did wrong. It happened again. Sorry about that.
I just want you to be able to do this on your own. That's why I'm having you do it. So that when Matthew's not around, you still feel like, hey, there's a tool I can use and go to Desmos and get the answer.
Okay, yeah, it's 10.10.
Good. So there are two values we found. The minus, I got them written on this other screen, -7.73 and 10.11. We want the positive.
Right.
All right. Any questions on that before we move on to the next one?
No.
All right. Next one is about a juggler. Juggler. What do you think about jugglers? Are you
They're
impressed by them or not?
Yeah, it's pretty cool.
How come they have to always throw something like more extreme for you to get excited? You know, like they could start out with tennis balls. You're like, yeah, no big deal. And then they get a chainsaw out or a flame, you know,
Yeah.
fire. And it's like, we should just be impressed with, you know, tennis balls, but we're not.
Yeah.
All right. A juggler throws a ball into the air, releasing it 5 feet above the ground. That's H. Initial velocity of 18. That's V. If she also catches it 5 feet in the air, then they're telling you now that H is 0, so it's not 5. How long is the ball in the air? So the scenario here graphically is the juggler. Oops, that's really bad. Let me redraw that, please. All right, so the juggler, they throw the ball up and it comes back to that height, which is 5, but they're saying no, treat it as it's really 0. Okay. G is minus 16 or 16, but it's minus GT squared. Could you write the equation for us, please?
Sure. At minus 16t squared plus 18t.
Okay, I'm just switching to X, but yep, that's correct. All right, now the question we're asked here is, I'll highlight it here. How long is the ball in the air? What does that correspond to here graphically?
Um, so yeah, it would be x.
X intercept, yes. Okay. All right. We did one kind of like this earlier. What method do you think we should use here?
Set the thing to 0.
Yeah, sorry. After we set it to 0, what type of factoring should we use?
Greatest common factor.
Yes. All right, so just in the interest of time here, I'm pretty sure you know how to do this. I want us to move on to 5 so we get full coverage on all these problems.
All right.
But I think you can do that. You can always use quadratic formula as well. All right, a rocket is launched from a hilltop at an initial velocity of 400 feet per second. That's the velocity. If the hilltop is 576 feet above the ground, how long before it hits the target that is located on the ground? So if you want a drawing here, here's the rocket and goes up and hits the ground. Looks like 2 mountains or 2 hills, but that is the rocket. All right, so the 576, what does that represent in the equation?
It'd be h height.
It is H. Yep. All right, so this equation is minus 16x squared plus 400x plus 576. And boy, these questions are not very unique. It always asks how long before it hits the ground, which again is the x-intercept. So let me know when you get all that down. Then I want to talk about how to actually do this. Try to save you some time.
All right.
So the fact that you already have in your Desmos these equations right here, if you just change your A and your B and your C to the new numbers, it will calculate the new intercepts. That's the power of like using a calculator, computer programming for that. What would A be? What would B be? And what would C be in this problem?
A would be -16, B would be 40, and C would
400.
be
400.
400. And C would be 576.
Okay, so go back to wherever you've got that open and just change those numbers if you need to. Like A is the same, and you'll see the numbers recalculate
Yeah.
as you go. So whenever you do that, give me your answers for the x-intercept, please.
We got -1.37 and 26.37.
Okay, which is the correct answer?
26.37. Because it is positive, I think.
Yes. And that is the time that it takes for the rocket to hit the ground.
Yeah.
Okay, so we'll just scroll back up quickly to number 4 here. You can use GCF. You could also go and type in A equals -16, B equals 18, but C this time is 0 for the previous problem because there's nothing that's being added to it.
Okay.
So if you don't change C, like if you forget to edit it because you're moving back and forth, you'll get an answer that you don't expect.
Okay, I got 1.13 and 0.
Yes, very good. So you should choose the positive one there, the non-zero one. All right, so we're going to go ahead and stop right here for today.